I'm going to be walking you through how to run the function calling example Samir just walked us through in Predifine. So I've set up this notebook here where we're going to set up our data set, our reward functions, and then start a training job in the SDK. And then we're going to flip over to the app and take a look at the observability tools we built to help you understand how your training jobs are working. So first off, we're going to install the Predibase SDK. I've already gone ahead and done that just to save some time. Next up, we're going to load our Glaive function calling dataset. This is the same data that Samir was just walking us through. And we're just going to take a look at this real quick when it downloads. So here we have just a few rows from the data set. When you're training with RFT in Predifine, the only requirement for your data is that each example has a prompt field that contains the prompt you're going to run through the model during training. You can also include optional additional columns fields like this one, the tool call, which we're going to use later on as a sort of ground truth to check the model output and generate our rewards. So if we, just as an example, if we look at one of the prompts, so we're giving it the task of, your task is only to select the correct tool, given a user message and a list of possible tools that you can use. You should use at most one tool per response. We're also directing the model to place its reasoning inside of a pair of think tags and to place its response, its answer, inside of a pair of tool tags. And so for this example, the user message is, can you tell me the current stock price of Apple? And we tell the model that it has access to a tool called get stock price. And we would expect in the output to see the model select the get stock price tool and give it the argument AAPL for Apple's symbol. From here, you can write your, if you haven't already uploaded the dataset to Predibase, you can write your dataset, the dataset to file, and then later on I'll show you how to get it into our system. Next up, we're going to look at the rewards functions and how you would set these up to work with our rewards server. So all rewards functions in Predibase are just standard Python functions that require 3 arguments: the prompt to score, or that was used to generate the completion, and then a dictionary containing that will contain the full example, the full row of data at runtime. And these should each return, any reward function you write should return a single float a value between 0 and 1, where 0 is no reward and 1 is the full reward. So yeah, let's get started looking at our reward functions for this. So the first, like Samir told us, is the correctness function. In this, we're going to check that the model output the correct tool and arguments as an answer. We give it partial credit for choosing the correct tool, or choosing full credit for choosing the no tool if no tool was required, partial credit for recognizing that a tool is required, choosing the correct tool, and giving it the correct arguments. And if it gets all 3 of those pieces correct, we give it a full 1.0 reward. If you need any external packages, for example, we're using some of the standard library packages here. You just need to import them inside of the function, and you'll have full access to whichever packages you are importing. If you need a package from pip, you can configure the fine-tuning job to recognize that need, and we'll pull it in for you at runtime. And then also, just as an example, you can see how we would get any additional information from the example dict here. So like we directly want to check against the expected tool call in this reward, and we're provided the tool call through the example dict, and then we just go through and extract the predicted tool call from the completion. Let's go ahead and that. Okay. Next up is our formatting reward function. And again, this is just checking that the model is formatting its responses as we directed with the think tags and the tool tags, and that any predicted tool has both a name and an arguments key fields inside of it. We give partial credit for having some of the tags. We give partial credit for only having one of each type of think and tool tag. And then we give the final bit of credit for structuring the predicted tool correctly inside of the tool, the tool tags. And then we're going to add one more reward function here. So this is going to put a limit on the size of our completions. In those agentic systems where there's a lot of communication, you need fast responses to direct to the correct tools. You don't want very wordy models. You don't want models taking too long to output their completions. So we're going to put a hard cap of 2,000 characters on any completion. If the completion is longer than 2,000 characters, then it gets a 0. If it's less than 2,000 characters, it gets a 1. And so with that, we have, just as a reminder, 3 reward functions. We're checking for correctness. Did it solve the problem correctly? Formatting, did it follow our instructions on how to format the response? And length, is the model being concise? And these are going to trade off during training to sort of mold the answer into what we're looking for, mold the completions into what we're looking for. And with that, we're going to set up the Predibase client, upload our data, and kick off a fine-tuning job. So here you'll see we're grabbing the Predibase client from Predibase package. You pass in the API token, which you can get from the settings page in the app. We're going to attempt to upload the data set. Now you'll notice I didn't actually write out a file here. I already have this in, but if you had not written, if you didn't already connect the function calling data to Predibase, this is how you would go about it. You just use our from file to push a local file up to the platform. And finally, we are going to kick off the training job. So first, we're going to get or create an adapter repo, and this is just a way to organize adapters if you're training multiple on the same or even different data. You can keep track of their performance that changes over time. And we're going to configure the RFT job here. So the first thing you'll see is we have this GRPO config object. This has a number of parameters that are central to running the job, like you specified the base model. So in this case, we're going to be training a Quinn 2.57 billion instruct adapter. We're going to specify that for each prompt on each epoch, we're going to generate 16 completions. And this can be changed to make training run more quickly or to generate more completions if you want to try to sample a wider variety of completions. Like with other inference or prompting, you can set some sampling parameters like max new tokens to control the max length of your completions, temperature to control the variability of your generated text, top P, top K. A few and other parameters that affect text generation. And lastly, we're going to pass in our reward functions. So we have this reward functions config that you give a human readable name or any name to pass in the functions. So we're calling them correctness, format, and length just for so that we can and we'll see in the app that's how they're referenced. We package the functions and ship them to Predibase. We handle all of that for you, so you don't have to do anything special. Just point the reward functions config to the reward functions you want to use. Then we give it our data set, our repo to store the adapter in, and an optional description, and we are off. Yeah, there. So we've started a new job, and now we're going to come over to the app. I kicked off a job about an hour ago to show everyone what a training job would look like in the loop. If you've used Predibase before, this page will look somewhat familiar. Has some details about the adapter, about training here at the top. But then the body here is immediately going to look new. The first thing you'll see is our reward functions tab, where you can view the functions that were submitted to this training job. So you'll see we can flip between our correctness, formatting, length functions here right in the UI. You can use this to spot check for any inconsistencies. You can use this to make sure that if you suspect there's an issue with your function, you can use this as a quick check to just see if anything jumps out at you. And later on, we'll see that you can track if you update the reward function, you'll be able to see all of the functions you've used right in this viewer. Next up, you'll be able to see reward graphs. So on this tab, you'll have one plot for each reward function. You're seeing here step level metrics. So every time we generate rewards, every step of training, we'll get a value back. These are averaged over the batch for the step. We also keep track of the total reward, which is a sum of our 3 reward functions here. And we keep track of the standard deviation of the rewards, so you can see how stable training is. And generally speaking, you want these to show an upward trend as training goes forward, unless you're getting full rewards. In which case, you might want to reevaluate your reward functions because maybe they're a little too easy for the model. Okay. On the next tab, you can see logs coming from the reward server. So these are pulled directly from the reward server as training is going. There are some sort of standard logs that every training run is going to get, just giving you a progress update, where you are, which epoch you're on, the dynamic timeout for the particular reward function that's being run. And then any print statements that you put into the reward function will also show up here. And that's going to be really helpful for debugging if you are still working on your reward functions. If you just want to see where you're ending up inside of the reward function, say you keep hitting a partial credit, you should be able to see exactly what's happening if you add in some logging. As you train, you can hit refresh here to get the latest logs. Also, if you switch off and back to this tab, it'll refresh as well. It's just a handy way to get some insight into how training is actually running. And the final tab is our completions viewer. So what this is a full list of the prompts and completions that have been generated over the entire course of training. So you'll see in this table, we have here are the first 10 prompts. They're a little truncated. We have a feature that lets you strip the sort of common parts of the prompt. So if you have prompt template, if you have system prompt that's common across all prompts, you can hit this, and it will just show you the relevant differentiated portion. For each prompt, you can see that for which epoch we've recorded the latest completions. You can see the average correctness score format score, length score from the current step that we've recorded for the prompt, as well as the total, and then the additional metadata that the additional columns that you provided with the data set. So here is the tool call that we're looking for this particular prompt. Scrolling down a bit, we've selected prompt 1 here. I'm gonna just switch this to prompt 3. We can see the full prompt right here in this viewer. You can read through, make sure everything is looking good, remind yourself of what this prompt is asking the model to do. And then right below that, you're going to see a side-by-side comparison of a completion, by default, the very first completion for this prompt in the first epoch, and the highest scoring completion from the latest epoch. And so you can kind of use this to keep track of how your model has developed over time, how completions are improving over time. Just flip through the epochs here really quickly and get a nice side-by-side, easy to understand view of how your model is performing. And if you want to see the full list of completions, they are all present down here. If you want to update the viewer, let's say we want to look at these two side by side, you just hit these L and R buttons. It populates up here, and so you have a lot of flexibility for running the comparisons between each completion. And you can also filter by epoch and reward function and value reward function. So let's just, yeah, there we go. So that's a quick overview of how we some of the observability tools we built to make RFT easy for you. One thing you may have noticed though is that when we're looking at these reward graphs, it looks like the length function we set up, which again was a hard threshold on the number of characters, is always returning 1. The model's always being pretty concise. But maybe a hard threshold was not really the intent of what we were trying to do. We want to encourage the model to be concise, but not pick an arbitrary number of characters as the max. So maybe to give something a little more informative, we want to create a sliding scale that gives a score relative to a max length here. So we're going to set up this updated reward length reward function that gives a reward based on the ratio of generated characters to that threshold that we set up before. And then we're going to update the running RFT job in place. So the first thing we're going to do is grab the path to the adapter, which if you're looking in the UI is this right here, and you can just copy it really easily. And then we're going to get the config for this training job. We're going to update the reward functions in the config. And then we're going to push the updated config to the job. We're going to run this really quick. And we'll see, there we go. Now, if we go back to the reward functions tab, you'll see that we now have 2 versions of the length function, our original that had the hard limit on completion length, and our more flexible version 2 of the length function. And this will be updated in place. So it would take a second. We may not see it here right away, but as soon as the next step completes, we'll see the length v2 function pop up here. Length v1 will stop populating this graph, and the average will update to account for both. So that is an overview of RFT in Predibase.